And welcome back. We are now going to go ahead and take our enemy and add our pathfinding ability to it. So to get started here, let's look at our enemy ship here. And I'm actually going to want to manipulate this prefab by go ahead and taking my enemy path script that I have here and attaching it to the enemy. So I'm just going to go ahead and drag that in. And so now this script is attached. Let's go ahead and make sure we have that override applied there to our enemy. So that is going to happen to any of the enemy prefabs. And then we can pop right into Visual Studio and go ahead and get ready to start updating the information that we want to have here for our enemy. So the first thing we're going to want to do is, because this enemy path is going to rely on our enemy waves, we're going to want to serialize our field here with what type of object. Well, we want a enemy wave, and let's just call this our enemy waves. And then we also are going to need to make sure we have set up a second variable, which is the list of waypoints. So we're going to create a list of transforms. And since this is just a list of our waypoints, we can just call this our waypoints. Lastly, we should probably keep track of which waypoint we currently are at. And so the easiest way to do that is just create a int that is going to keep the current waypoint index, and we'll initialize that to 0, just so we have a starting value, so we know no matter what, we're always going to have the initial position. So what we want to do is, when we first start up this object here, we're going to want, of course, to tell our waypoints. We want to have that set up in a way that it's going to get our list of waypoints. If you remember, our enemy waves have actually that in there. So if we say enemy waves and we do dot, we have get all waypoints. That will allow us to get that list of waypoints that are available. Next, we want to make sure we initialize our enemy to be at that starting waypoint. So we're going to want to make sure we include that here as a starting position. So the way we can do this, we can say transform.position. And what do we want to equal that to? Well, we don't want another vector 3 here. No, instead we want to use this information that we just got. So let's use our waypoints. And we're going to use the current waypoint index, because we want to see where is that waypoint currently at. And we want to, of course, get the position of that as well. Now this works for starting off our enemy spawning, right? But of course, we are going to want those enemies to follow along the path that we have transcribed. So we're going to want to have a method that says follow waypoint path. And of course, we don't currently have this here as a method, so we can actually just go ahead and create this method. So generate method, there it is. We're going to delete out that throw statement there. And what we want to do is set it up so that way, if the waypoint index, or the current waypoint index, is less than the waypoints.count. So that means as long as we are less than the total number of waypoints, we're going to want to have that enemy keep moving toward that waypoint. Because if it hits it, well, that means we're done moving. If it is less than it, we want that enemy to keep following that path that we've laid out. Now, if we start thinking about how we want our enemy to move along this path, we have, of course, are really kind of keeping track of 3 kind of primary things: where our enemy currently is, where they're going, and where we want them to finally end. So let's go ahead and start this off by creating another vector 2. And since, of course, we're using the position is an important thing, we'll call this our target position, because we want this to say this is where we want this to be. And let's just go ahead and take this suggestion here, take a look at it, and see if this is correct. And so Visual Studio has suggested this, and I'm going to accept it because we want the list of waypoints, and we want to get that current waypoint index. And we want to, of course, record that position of it. And so we're going to store that here in this target position. Now we also, of course, need our speed here. So let's just go ahead and, for our purposes, take that suggestion out of there from Visual Studio. There we go. And let's create a float that just we'll call this our delta speed. And we'll set this equal to our enemy waves dot. And remember, we have a move speed in here. So get enemy speed, there we go. Open close parentheses. Now this would work, but we also want to make sure we have a frame rate independence here. So we're going to use time.delta time to make sure we maintain that frame rate independence. Now we of course want this to, we kind of have a suggestion here from Visual Studio, trying to be helpful here. We do want transform.position to equal something, but we don't want to just simply equal itself. Instead, we want to have this be another vector too that's going to kind of control that ability for it to move towards. So we're just going to go ahead and say vector2 dot, and there's a method built in that says move towards. Now if I just use this as is, you can see it's complaining because if I hover over it, you can see we need a list of parameters here. So we need a current vector2, we need a target vector2, and there's a float for the mass distance delta. So let's just go ahead and plug these in. So we know the first thing is going to be our transform.position. Our next vector should be our target position. And then finally, our delta speed should fill the quantity that we need for that max distance delta. So let's go ahead and put delta speed. Now what happens when we finally reach that destination that we're looking for? Well, we can do that with a quick if statement to check things. So we can say if our target position and our transform position are equal, we can then take an action. So let's just do transform.position and see if it is equal to our target position. And you can see Visual Studio is being helpful here and suggesting we just take our current waypoint index, increase it by 1, which is exactly what we wanted to do because we want to be able to move to that next waypoint along that path. Now we do have an error here. If you look, it says there's a difference between vector 3 and vector 2. That's because transform position relies on a vector 3. So to solve this, we're just simply going to change the target position to vector 3, and that should resolve that issue for us. Now the last thing we need to do here before we go ahead and say this is all good is that we need to see what happens once we reach the end of that path. All right, what are we going to do? Well, we probably want to have an else statement here that is simply going to destroy our game object, because once we reach the end of the path, that's it. All right, the enemy's going to go off the screen, and that will be the end of that enemy. All right, so back over into Unity, we can now come in here and start manipulating this. Since our enemy path is already prefabbed, we can actually technically take that out of here. And let's go ahead and focus in on our enemy, and you can see now we have enemy waves here. There's no enemy wave currently defined. So here inside of our enemy waves, again, we have nothing. So the way to fix that is we're going to go to our waves, and in here, I'm just going to right-click and create. And you can see at the very top, I have the option for enemy wave config, so I can just go ahead and click that. And let's just define this as wave 0. And so now I have a file here that should work pretty well. Now we do need a path prefab, which of course we have one right here. So let's go ahead and drag the enemy path right up in here into this, so it's no longer none. So now that is applied there as well. So I'm going to go ahead and click on my enemy now. Let's go ahead and update the enemy waves here with our wave 0. That looks good. We'll make sure we click our override here to apply that to our prefab. So now let's just go ahead and test this out and see if our enemy go ahead and follows that path that we defined. And you can see it comes off screen and it follows it right off. Pretty great. All right, and so now I'm going to leave you with a small challenge. So we of course have gone and created our first enemy path, and we created a enemy wave. But my challenge for you is go ahead and see if you can create a secondary enemy path, even if something as simple as maybe the enemies just move straight across the screen, or maybe they come in at the opposite angle. Go ahead and create that path, and then of course set up a new wave that would follow that other path. So that's my challenge for you, and then we will see you next time when we can add yet another dimension to our player and enemy movement.